Okay, so give the IUPAC nomenclature to the given different complexes. Okay, so we need to give the IUPAC name to these different coordination complexes, and okay, so one by one we will take each complex and we will do the nomenclature. So in order to do the nomenclature, we need to understand some points. Okay, the points are basically the you need to understand that what kind of the species we have given. Okay, sometimes we have the neutral species, all right, and sometimes we have the cationic species, and sometimes we have the anionic species. Okay, so firstly we need to understand that what kind of the species we have. Okay, once we figure out the type of the species, then we need to understand that how to do the nomenclature. Okay, so there are some common rules that we studied in the organic chemistry. Okay, so that kind of the thing we will use. For example, we will talk about the hexa, bi, tri. Okay, so how many ligands are present? Suppose 6 cyanide are present, so we will write the hexacyano. Okay, so suppose 6 chlorine are present, so we will write the hexachloro. Okay, so that kind of the thing we need to understand. And then in case of the anionic species, anionic complexes, we need to use some suffix. All right, suffix that are the basically added after the name. Okay, and in all these coordination complexes, one thing is common, that we need to assign the coordination oxidation state to each central metal atom. Okay, so that is very very important, that in which case the what is the oxidation state of this central metal atom. Right, so let's do the first nomenclature. So basically in this first case we have the potassium and then this Fe hexacyano. Okay, so you can write here like this is the coordination sphere. Okay, so in the coordination in this anionic is ionization sphere, you can write the 4 potassium positive and hexacyano like this, right? So once you write like this, then you can see that we have this is the cationic part and this is the anionic part. Okay, so in all these cases, first we will do the nomenclature of the cationic part. Okay, so we will write here the potassium, right? Then now come to the this anionic part. We will firstly talk about the ligand. So we have the 6 cyanide ligand. Okay, so we will write as hexacyano. All right, hexacyano. Then ferrate. Okay, so why we are writing the ferrate? So ferrate, because this is important. Why we are writing the ferrate? Okay, so it is due to the this have the negative charge. Okay, so remember that whenever we have the anionic species, then we will write the suffix as the aid after the metal. Okay, so we have the iron as the metal, that is the ferrous. So we okay, so we will write the ferrate, right? And then we assign the oxidation state to this iron. Okay, we already know how to assign the oxidation state, so iron is present in +2 oxidation state. So the IUPAC name of this complex is the potassium hexacyano ferrate 2. Okay, so let's see the next complex. So here we also have the same kind of the thing, potassium. Okay, so we will write here the potassium. All right, potassium hexachloro. Okay, platinum is the central metal atom, so we will write the platinate. Okay, platinate. Why 8? Because this is also having the anionic species. Okay, this is the anionic part. The coordination sphere is anionic. Okay, so the oxidation state of the platinum is +4 in this case, so we will write the +4. Okay, now let's see the next. So we have this cobalt and hexaamine, okay, and then this chlorine. So you can see once you do open this ionization sphere, you will write that this cobalt hexaamine, okay, this will be your +3 and these 3 chloride will be your minus, right? So you can see this coordination sphere is the plus, okay, that is the, it is positive, so you can say that's your cationic species. So in the cationic species we don't use the suffix, okay, so just do the nomenclature. So hexaamine, okay, we will write the nomenclature from the positive species, okay, so we will write the hexaamine cobalt, oxidation state of cobalt is +3 here, okay. So once we did the nomenclature of this positive species, that is the hexaamine cobalt 3, now there is a part of the this negative, okay, anionic species, so that is the chloride. So we will write here simply the chloride. So the name, IUPAC name of this is the hexaamine cobalt 3 chloride, okay. So let's see the next question, number 4. So we have this ionization sphere. So firstly we will write this, how to write this. So you can write here the chromium hexa aqua, sorry, that is the tetra aqua and Cl2, right? So that would be your plus charge and this chloride, okay. So we will do this nomenclature of this positive coordination sphere. So we have the, now we will go with the alphabetical order. We have the tetra aqua species and dichloro species, okay, dichloro species and the tetra aqua. So we will write from the tetra aqua, right, tetra aqua. For water species we will write the aqua, tetra aqua, then dichloro, okay, dichloro, all right, tetra aqua dichloro. So firstly we assign the ligands, and now there is a term of the central metal atom. So that is the chromium, okay, chromium, and oxidation state of the chromium will be +3 here, and then the negative, this part, that is the chloride, okay, that is the chloride. So the name is the tetra aqua dichlorochromium 3 chloride, okay. Now let's move to the final question, that this is the platinum, okay. So you can see here this is the neutral species, okay. So this is the neutral species. So we will do the nomenclature from this diamine. For ammonia we will write amine, so that's the diamine tetrachloride or tetrachloro, okay, tetrachloro, and okay, what we have is the diamine tetrachloro platinum, right, platinum, and oxidation state is the +4, right. So that this is the diamine tetrachloro platinum +4, okay. So these are the few things that we need to understand to do the IUPAC nomenclature of the coordination complexes, right.